Dr. Nardi here, back with another video. Please like, subscribe, and share this video if you like it. If you don't like it, leave a comment below and let me know why. Now, in this video, we are going to talk about sleep and dreaming. Now, think about this. Each night, we go to sleep and we fall into this mysterious state of not being entirely conscious, but also not being entirely unconscious. Now, sleep has been a mystery for thousands of years. And if we look back in our ancient past, our forebears used to suggest that our soul would leave our body and it would wander around the world during our sleeping hours. However, we know that's not the case. Many research studies, although we know that doesn't happen, are still unclear on some of the most basic questions, like what is the function of sleep? Now, you could say, well, the most obvious explanation is that it's restorative. Now, there is a lot of evidence that supports this observation, that kind of shows that, yes, it's restorative. A less obvious explanation is it's adaptive. Now, according to this view, the amount of sleep an animal engages in depends on the availability of food and safety considerations. So, for example, elephants, which actually have to eat or graze for hours to meet their food needs, sleep only briefly. Animals with low vulnerability to predators, such as, lions, sleep much of the time, as do animals that find safety by hiding, such as bats and animals that burrow under the ground. Vulnerable animals that are too large to kind of burrow under the ground or hide, like horses and cattle, sleep very little. So again, there's a lot of things that go into sleep and why we sleep as much as we do. Now, regardless of the function of sleep, and we can debate why we sleep and what's the function of sleep, I think a very important thing to look at is what we call sleep deprivation and the negative effects of not sleeping that much. Now, these effects are very evident if we look at people who work in shift work. Shift workers sleep much less than day workers, and their work performance suffers as a result. Shift workers typically fail to adjust to their sleep-wake cycles adequately. Partially, they fail to adjust because, during the day, their sleep is interrupted, and then on the weekends, they have to kind of go back and conform to the world schedule because, most people are awake during the day and sleep at night. But however, these shift workers have to do the opposite. And what happens is their sleep schedules are at odds with their biological rhythms. So sleep can actually intrude with their work. And their daytime arousal interferes with their sleep. Because again, humans are diurnal, not nocturnal. Now, we have done long-term sleep deprivation studies, and we look at that impairment, and it follows a rhythmic cycle. Performance declines during the night, and then shows some recovery during the daytime. The persistence of this rhythm can be a safety hazard of immense proportions, especially when people are trying to function at night. The largest number of single vehicle traffic accidents are attributed to falling asleep at the wheel, and this occurs around 2 a.m. And the number of work errors peaks at the same time. Now, here's a good one. If you think about 3 Mile Island, that nuclear plant accident took place at 4 a.m. The Chernobyl nuclear plant meltdown began at 1:23 a.m. Again, there could be something going on here with these accidents happening so early in the morning. Traveling across time zones also disrupts sleep and impairs performance. particularly when you travel from west to east. Now, it's kind of hard to quantify what exactly jet lag is, and researchers kind of struggle with this. But we've noticed that people who have jet lag have impaired cognitive abilities because their sleep cycle has been disturbed. Now, what controls this sleep wake cycle is the circadian rhythm. And the circadian rhythm is about a day in length. And so it operates on about a 24-hour cycle. And it's in synchronous with a solar day. So we sleep once every 24 hours. And our body temperature, alertness, urine production, steroid secretion, and a variety of other activities decrease during our normal sleep period and increase during our normal waking period, even if we reverse our sleep-wake cycle. Now, the main biological clock that controls our rhythm, in mammals anyway, is the suprachiasmatic nucleus, or SCN. I think I'll just say SCN. Of the hypothalamus. Now, we know that if there's a disruption to the SCN, like a lesioning that can happen in rats, this kind of messes up their 24-hour sleep-wake cycle. It messes up their body temperature, their drinking water, and their steroid secretion. Now, we think about the SCN as a kind of pacemaker, because it keeps time and regulates the activity of other cells. We know that the rhythm arises in the SCN because rhythmic activities continue in isolated SCN cells. Now, referring back to those lesioned animals, they don't stop sleeping, but instead of following the usual, day-night cycle, their sleep is disrupted. So they'll sleep in naps that are scattered throughout a 24-hour period. So basically, the SCN controls the timing of sleep, but sleep itself is controlled by another brain structure. Now, the SCN also controls the production of melatonin, and daylight resets that biological clock every day by suppressing melatonin secretion. Now let's talk about sleep for a moment. Now, most people think sleep occurs when your body and brain become fatigued. Sleep, however, is actually a very active process. And we can look at it in basically two respects. First, sleep is actually a very busy time. We're to talk about what's going on in the brain when you're sleeping. But there's a lot of activity that goes on. Second, sleep is not like when your car, runs out of gas, or electric car runs out of battery, but it's instead turned on by the brain structures and later turned off by other structures. So it's actually a timed event. Now, how do we measure sleep activity? So when someone goes to sleep, we can hook them up to an EEG. And what the EEG does is it looks at a mix of alpha and beta waves. Now, we can look at alpha and beta waves. Alpha waves are activity whose voltage fluctuates at a frequency of 8 to 12 hertz and has what we call a moderate amplitude. Beta has a frequency of 13 to 30 hertz and has a lower amplitude. Beta waves, which are associated with arousal and alertness, are progressively replaced by alpha waves as a person relaxes. Now, it may seem strange if we think about this, that the amplitude of EEG is lower during arousal. But remember, an EEG is just a sum of electrical activity of all the neurons between the two recording electrodes. Now, what an EEG does is they put a bunch of electrodes on someone's head, and we can actually measure these brain waves. Now, when a person is cognitively aroused, neurons under the electrodes are mostly desynchronized in their firing as they carry out their separate tasks, with the neurons firing at basically different times. The EEG has a higher frequency, but the amplitude is rather low. As a person relaxes, neurons have less processing to do and fall into a pattern of synchronized firing. The rate is low, but the cumulative amplitude of the neurons firing at the same time is high. So that's why you kind of get that low to high change. Now, we could talk about sleep in stages. As a person slips into the first stage of sleep, the EEG slips to theta waves, which is a frequency of 4 to 7 hertz. And about 10 minutes later, stage 2 begins, indicated by the appearance of K complexes and sleep spindles. Now, K complexes are sharp, large waves that occur about once per minute. Sleep spindles are brief bursts of 12 to 14 hertz waves that appear to serve as a gating function, basically preventing disruptive stimuli from reaching the cortex and waking the sleeper. Stage 3 and 4 are known as slow wave sleep and are characterized by large, slow delta waves of a frequency of about 1 to 3 hertz. Now, a person moves around in the bed during this period, turning over and changing positions. If we're talking about sleepwalking, bedwetting, and night terrors, these are that actually, by the way, are common in children. These all occur during slow wave sleep. Now, night terrors, by the way, are not nightmares, but involve screaming and apparent terror, which are usually forgotten about in the morning. Now, they are not a sign of a disorder unless they continue beyond childhood. After stage 4, the sleeper moves rather quickly back through the stages in reverse order. But instead of referring to stage 1, the sleeper enters rapid eye movement, or REM. Rapid eye movement, or REM sleep, is characterized by rapid horizontal movement of the eyes. So if you looked at someone's eyes, they'd be darting back and forth. And if you look at their frequency on the EEG, it is in the beta range. Now, during REM sleep, respiration rate and heart rate increase. Now, also during this time, the body is very still. In fact, in a state of muscular paralysis. Now, it's interesting because a lot of researchers call this paradoxical sleep because it's contradictory, right? So, you can't move, but your brain is going and processing and thinking and going through daydreaming cycles about every 90 minutes. So it takes about 90 minutes to complete this whole cycle. So what is the importance of sleep? Well, in children, researchers have kind of looked at neural development, and they notice that sleep is rather important for neural development in children. There's also talking about how your brain is still developing, and for example, your visual system is kind of still developing, and sleep plays a critical role in this. Also, too, for adults and children, sleep is important for memory and retrieving and storing information. So you learn something during the day, and then at night, your brain will consolidate that information in this multi-step processing, right? And it kind of requires slow wave sleep and REM sleep. But we notice that when people get good night's sleeps, they remember better. So, FYI, do not stay up before a big exam trying to cram all night. That is the opposite of what you want to be doing if you want to perform your best on that exam. With that said, that is all for this video. Please like, subscribe, and share. Leave a comment below, and I'll see you all next time. Take care. Bye-bye.